We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside.
Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, A landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where two tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia, these are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes.
Kiev, you've been dreaming of getting here for years. Getting out your trusty camera, you start taking pictures of the cathedrals, aviation museum, and the Dnipro River, when, without warning, there's an enormous boom behind you. Turning around, you see something towering in the distance. It looks like a gigantic explosion. Uh-oh, time to leave fast. In June 2020, what the people of Kiev were looking at was an anvil cloud, a rare storm formation in the sky. Forming when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud just 60 miles away, thinking something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area, regardless of how strong the wind is. Touring around the northern tip of Queensland, Australia, way away from those creepy crawlies, it's time to take a break and relax at the beach. Getting comfortable, you notice a great big shadow passes over you, then another, and yet another. Looking up, this weird weather is simply stunning. The clouds are called morning glory, a very rare type of cloud that almost seems to roll across the sky, looking like a massive tube. These clouds can measure up to 600 miles long, even appearing in large groups as well. This phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance, while moist cooler air at the back causes them to sink downward. Southern India between July and September 2001. People witnessed one of the strangest weather phenomenon in recorded history. The rain was red. What many would have thought to be a typical rainstorm left them shocked. The color was bright enough to stain clothes. There were other colors too, such as green, yellow, brown, and even black. In the middle of a monsoon, red rain started to fall, and did so periodically for several weeks. Researchers have found this unusual rain is stained either by dust or algae, so don't try to catch any on your tongue. Scientists aren't entirely sure how the algae got all the way up there. This does make events like this a little unsettling. Like to take a bubble bath to relax after an exhausting day, but taking too long to fill the bathtub? Problem solved. Head to any coastline after a big storm and take a dip. Foamy tides aren't native to any one place or location. They can be formed anywhere in the world. They're most likely to happen along rocky coastlines, like the coast of San Francisco, Northern Ireland, or the Mululaba, Australia. Each coast has differing conditions forming the sea foams. If you scoop up seawater into a glass and look at it closely, you'll see it's full of tiny particles. Many things like plants, chemicals, and lots of salt and minerals create the perfect formula for foam. When powerful currents and wind mix it all together, we get something that resembles a cappuccino top floating on top of the water. When freezing temperatures hit orchards in Michigan, all kinds of unusual things happen, like ghost apples. No, they're not going to scare you at all. But if you plan on sneaking away one winter to find one, be warned. Everything has to be perfect for this to occur, and it's going to be freezing cold. This is actually a rare weather phenomenon caused by having the apples freeze where they are with rain coating the fruit in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Catatumbo River in Venezuela might be the most electric place in the world, with nearly 300 storm days per year. The lightning storms are so consistent, they're predicted for 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute, a truly shocking experience. With each bolt having the energy to power a single light bulb for 6 months, the impressive display could power all of Venezuela forever. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. As the water droplets of humid air collide with ice crystals from the cold air, it produces the static charges that cause the lightning storms nearly every night. If that wasn't bad enough, some storms have lightning above them as well. Try to take a picture of this one. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they have nothing to do with rain. These sprites occur 30 to 50 miles up in the sky, in the mesosphere. Artificial lights at night make it a lot harder to see this faint lightning. If you spot one, it'll look tiny, but can be well over 30 miles wide. The red sprites are a type of cold plasma discharge above a thundercloud. They're the balance of the lightning charges between the storm clouds and the ground below. Don't try to find this type of donut at your favorite bakery. It won't be there. Snow donuts are one of the rarest meteorological sights to see, with perfect weather conditions needed just to create them. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for us to see these phenomenal rings. A thin layer of wet snow on the ground. Under that layer, ice or powdered snow. Then, a strong enough breeze to roll the donut down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind is. A newly formed snow donut won't stay around for very long, so hurry up with that camera. Watching the sunset over the horizon, the beautiful purples and pink overhead are nothing compared to the 3 suns you see in front of you. Wow, since when did Earth get 3 suns? These phantom stars sometimes appearing beside the sun are called sun dogs. Maybe they're called that because they're kind of dogging the actual sun? Sundogs often appear as colored areas of light at the same height above the horizon as the sun. They're mostly observed on a ring or halo, where ice crystals best reflect the light. There are also moon dogs that appear alongside the moon and are formed by lunar light passing through ice crystals, though these aren't seen nearly as much as their daytime partners. Taking photos in the wild, you finally found the perfect spot to take that dream shot. The crystal clear water, the pines, the mountains, and the flying saucer. Wait, a flying saucer? Oh, aliens are here! You might be thinking this if you saw a saucer-shaped cloud. I'm not even going to try to pronounce their name though. Put that on the screen, please. Wait, just kidding. It's altocumulus lenticularis. Aren't you impressed? These are really just unusual cloud formations over mountaintops. When moist air flows over a mountain, a wave is created if the temperature difference is perfect. As the air passes through the wave, evaporation occurs and a series of these clouds may form into an oval shape. Not aliens at all. Whew! The sky is falling! The sky is falling! Well, people who have experienced these clouds say they look like they're coming down from the sky. Mammatus clouds look like giant white lumpy marshmallows, but it might be hard to toast these ones. These weird fluffy clouds can extend hundreds of miles in any direction, remaining visible for short periods at the bottom of anvil or other thunderstorm clouds. The strange bubble shapes are formed from turbulence within the storm itself, creating an uneven cloud base and appearing anywhere in the world. Mammatus clouds form when moist air sinks into dry air. The air must be cooler than its surroundings, cooled with ice, or be heavy with water. Ah, a purple sunset. You must have seen one of those at least once in your life. Normally, it's nothing ominous and has to do with the way light travels. The light that the sun produces is white. When it goes through a prism, you see light waves of different colors, from red and orange to blue, green, and indigo. Light normally travels in a straight line if there's no obstacle in its way. The shorter light waves, including blues and purples, are scattered easier when they meet with those obstacles, like molecules and aerosols in the atmosphere. Because the sun is low on the horizon at sunset and sunrise, its light has to pass through more molecules that scatter the violet and blue light. The colors that your eyes pick up, then, are yellow, orange, and red. But, with the right conditions, you can see the gorgeous purple sky. Sometimes purple sky appears for much scarier reasons. It can be caused by hurricanes, wildfires, or dust storms. The concentration of vapor in the air increases, and the light scatters more than usual. Dust, a setting sun, and low cloud cover all contribute to this natural show, too. The sky turns orange and red at dusk if there's still enough light. Then it gives off pink hues, which mix up with a dark blue sky above. Now, do you remember what happens when you mix pink and blue? You get the color purple. Not every hurricane makes the sky turn purple, and trying to predict if it's going to happen is like trying to forecast a rainbow. Still, people reported several major hurricanes made the skies turn purple. Now, green skies might look just as spectacular as purple ones, but they actually also scream danger. They're usually there to tell you a thunderstorm, hailstorm, or a tornado is somewhere nearby. The unique color is a result of yellow sun rays getting mixed with the blue light coming from storm clouds. So you're enjoying a nice day by the ocean with a fresh breeze in your hair, when suddenly you notice the water starts retreating from the beach at a huge speed. This is a sign for you to start running as fast and far away from the beach as you can. This most likely means that a tsunami is on the way. A quick reaction maximizes your chances of survival. Now, if you notice the sea level is rising, But it doesn't seem too extreme. It could be another sign of an approaching tsunami. It happens in 40% of cases, and the incoming water is the first tsunami wave. The next one, way larger and more dangerous, usually follows in about 10 minutes. Another thing about tsunamis is that they like to arrive with some loud sounds. People describe them as thunder, the sound of a locomotive, a helicopter, or just a loud boom. Do you see a channel of choppy water on the beach? It's in your best interest to stay away from the water. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange break in the waves, or an area with a different color than the rest of the water. Random bits of seaweed going in all directions is another rip current warning sign. If you happen to find yourself caught in a rip current, try to stay afloat, but don't try to go against the current. You'll only waste precious energy. Scream for help and try to float your way along the beach. Once you break out of the current, swim diagonally to the shore. The next time you spot conically shaped clouds in the sky, remember it's a good time to start looking for some shelter. If it just stays like that, a severe storm is on the way. But if a cloud of that shape starts spinning around, it means it's about to transform into a tornado. If you have bees nearby, they can save you from big trouble one day. These hard-working little guys get more active than usual when they feel like a storm is on the way. They speed up to collect more nectar before it hits them, and once they're done with it, they'll always come back to the hive 10 to 15 minutes before heavy rain, even when there are no obvious signs of it coming. Their secret is super-sensitive hairs on the back that can pick up electrostatic buildups from storm clouds. For centuries, people have noticed that animals act weirdly a couple of days before big seismic events. Dogs can't stop barking, cows halt their milk, and toads, rats, and snakes leave their homes. It looks like animals can feel smaller initial shock waves that humans don't even notice. Scientists have tried to find some legit explanation for it and run endless tests and experiments. But so far, they're still on their way to explaining this mystery. Can you smell ozone in the air? When a thunderstorm is on the way, it's the most distinct and pungent smell you can pick up. An electrical charge of lightning sets it free from higher altitudes. The other, more pleasant smell of rain is petrichor. Rainwater wakes up molecules on plants, trees, concrete, and asphalt. Their aroma spreads all over the place. You can even feel that smell in your own mouth. All those positive ions in the air that a lightning bolt sets free gets mixed with ozone and your saliva, and that's how you get that bitter metallic taste. When lightning is about to strike, you might hear bizarre crackling, buzzing, or vibrating sounds coming from metal objects nearby. Your palms may begin to sweat, and then you can feel your hair stand on end. That's a clear call for action, and that action is to run for your life. Positive charges are going through your body trying to reach toward the negatively charged part of the storm. Trust me, you don't want these charges to meet. If you see no shelter that you can reach fast, try to make yourself smaller than the objects around you. Drop down your umbrella and stay away from wire fences, metal pipes, rails, and other metallic objects. And don't lie flat on the ground, it's likely wet, which means it's a great conductor of electricity. If you suddenly notice crevices in the asphalt next to your house, it could be a sinkhole warning sign. Inspect your house on the inside. Does that door begin to jam? Or maybe there's a gap where the walls meet the ceiling. Uneven kitchen cabinets and drawers, slanted floors, stairs that begin to slope, water leaking after every rain, and displaced moldings are all signs that a sinkhole is about to open. To find out if it's definitely a sinkhole and how dangerous it is, you gotta consult with an engineering company. If you find a sinkhole that's already there, you gotta stay away from the sinkhole area. Fence or rope it off to make it less dangerous for others. You'll need professional help to fix it. Some volcanoes scream when they're about to erupt. Small earthquakes, which often happen before, produce a hum. It's mostly non-audible to human ears, but sometimes it reaches a frequency that lets you hear it as a strange rumbling or hissing sound coming from the ground. This noise is known as a harmonic tremor. With some volcanoes, it's the sound of magma bubbles vibrating when they're going through crevices in the crust of the Earth. But it's not always like this. If scientists manage to understand what exactly causes these volcanic streams, they could create a limited early warning system for volcanic eruptions. If you're out in the wild, pay attention to the water in creeks, streams, and rivers. If its level is quickly falling, even if it's raining, this might be a sign of a nearing landslide. And if you hear a faint rumbling noise or unusual sounds, like boulders knocking together, it could mean debris is on its way to you. It's a sign to head to safety immediately, like right now. Hey, ever heard of a fire rainbow? Yeah, me neither. How about a circumhorizontal arc? Didn't think so, but just so you know, they're one and the same thing. At first glance, it looks like a painting, or like a rainbow-colored splash in the sky. Despite the name, they have nothing in common with either fire or rain. This phenomenon happens on rare occasions when the sun shines through a particular type of ice cloud formation. The rainbow halos are just as unique. Again, a specific type of ice crystals in clouds needs to be present for the surface of the Earth to bend light from the sun into a perfect ring. The same thing can happen with moonlight. The only difference will be that moon halos are usually white and sun halos can be rainbow-colored. When visiting regions with high altitudes, you may be one of the lucky people to stumble upon penitentes. They're basically naturally formed ice spikes. For them to be formed, they need a really cold and elevated environment where the air is dry. The sunlight turns ice directly into vapor rather than melting it into water. And that's why these blades of snow and ice start to pop up on the surface of the Earth. As cute as they may be, they can end up as tall as 15 feet. Now, what happens when small individual droplets of lava meet the wind? Pele's hair, basically. Let me explain. The word Pele comes from an ancient Hawaiian symbol for volcanoes. Whenever the wind picks up little drops of lava, it stretches them into hair-like strands, similar to the process of glass wire creation. These delicate strands can stretch as far as 6 feet. On rare occasions, it can rain without any clouds. But does it really? Let's look at the science behind this rare phenomenon. It's sometimes called a sun shower, just because it looks like the rain is falling straight from the sun. Let's be clear though, there is no way rain can ever come down directly from a star. Rain clouds are at a bit of a distance from that specific location. With sun rays being angled, the clouds become out of sight. Add a little wind to blow the rain in your direction and ta-da! You get sun showers. Located in Bolivia is a place called Salar de Uyuni. It's the largest salt flat in the world. It's also the home of half of the world's lithium, which is a crucial component for making batteries. But what else is so special about this place? Well, whenever the rain season comes, it turns this piece of flat land into a perfectly reflective mirror lake. What comes to your mind when you hear about the Blood Falls? A horror movie? Well, they are merely a series of waterfalls located in one of the driest regions of Antarctica. They emerge from an underground lake filled with a special kind of bacteria. These little organisms use sulfates as fuel instead of sugars, which makes them very intriguing for scientists. The water contained in this lake is so full of iron that it basically just rusts when it meets the air. Hence, the reddish color of the waterfall, which also gives it its trademark name. Okay, we all know the song, but it's not really made up. There is actually such a thing called a desert rose. It's not a plant though, but a unique form of the mineral gypsum. It develops in dry sandy places that can occasionally flood. This constant switching between a wet and dry environment lets the gypsum crystals emerge between grains of sand, trapping them and forming a rose-like shape. Ever heard of the Eye of Sahara? Scientists are still trying to figure out how it was formed. You can only see it if you fly above it, but it's basically a naturally formed dome that dates back to approximately 100 million years ago. And no, I wasn't around then. It has a rough diameter of 25 miles and consists of a bunch of concentric rings. The biggest one, or the central area, measures about 19 miles in diameter. Astronauts were some of the first people to notice it, and it's been studied ever since. In fact, even to this day, when landing in Florida, they know they're almost home when they see the Eye of Sahara. One of the most beautifully colored trees in the world is located in the Philippines and Indonesia. It's called the rainbow eucalyptus. It got its name because of its bark that switches colors and peels away as the tree ages. The bright green bark is the youngest, as it contains a substance called chlorophyll, usually found in leaves. It then switches to purple and then to the color red. And finally, it turns brown as it grows and loses the chlorophyll. Now, don't be tricked into thinking that's a whole forest. It's one single tree. And no, it's not some sort of optical illusion either. Let me explain. Underneath that soil, there is a complex network of roots that connects around 47,000 tree-like shapes you see above the ground. It's called the quaking aspen. Some of these trees are among the oldest and largest organisms in the world. Now, here's a good destination for all travelers, or maybe not so good after all. The most lightning-stricken area in the world, according to recent data released by NASA, is Lake Maracaibo in Venezuela. Out of all the days in a year, 300 of them feature thunderstorms in this location. What makes this area so unique, though, that storms happen so often? Well, it's because where cool mountain air meets the warm, moist breeze and generates electricity over the lake. The Eternal Flame Falls are located in upstate New York, near the Canadian border. In this region, there is a tiny waterfall with a big secret, a spark about 8 inches tall. Turns out there's a natural gas seep that provides fuel to the flame behind the waterfall. The waterfall provides enough coverage so that it stays lit pretty much every time. Hikers do enjoy to relight it if they see that it's been blown out. This phenomenon is actually quite common, but this one gained more popularity because it is younger than most. And it looks very good in pictures, let's be honest. I've heard of yellow sand, white sand, and even black sand here or there. But I've never heard of green beaches until now. Papacolia, also known as Green Sand Beach, is located in Hawaii and is one of the few beaches in the world that features green sand. The unique coloring comes from olivine rock that was formed when a nearby volcano erupted. Actually, in Hawaii, all the volcanoes are nearby. Move over green sands because some of the other beaches around the world can even glow at night, and it's completely natural. The culprit? A little thing called photoplankton, or microalgae as they're sometimes called. They're basically little plants that contain chlorophyll and need sunlight in order to live and grow. Most photoplankton kinds are able to float in the upper part of the ocean, where the sunlight can still reach them beneath the water. When the photoplankton gets agitated by the movement of waves and currents, they emit light, which looks like some glow during the night. These special microorganisms are found on beaches in a lot of places around the world, such as the Maldives, Puerto Rico, and the Everglades. At the base of a mountain located just outside of Afton, Wyoming, is a little river called the Intermittent Spring. There are only 3 of this kind in the whole world, but what makes this little string of water so mysterious? Well, the fact that it starts and stops every few minutes. Scientists have yet to pinpoint precisely why this happens. They speculate that it's basically just a siphon effect that happens deep within the ground that causes the river to just start and stop so often. Should you ever be interested in checking it out, be sure to do so in the late summer, as that's when the intermittent spring is most active. Do you see the irony here? You can only see the spring in the summer? Okay, I'm done.
You feel some rumbling from below. No, it's not your tummy. It's low and ominous. You look up and see strange lights hanging above the ground. They look like shimmering balls of light hovering high up in the sky. Your throat goes dry and you gulp. That's what they call the earthquake lights. This phenomenon is poorly understood, but witnesses say they've seen it in different shapes and sizes. It could be in the form of light balls, sheet lightning, streamers, and a steady glow in the sky. Soon after, a strong earthquake follows. Scientists can't explain why those lights appear, and they don't always do either. Some believe that's a reaction of underground gases released into the atmosphere. Sure enough, an earthquake begins. But lucky you, it's not as strong as you expected. The ground is shaking, but you even manage to keep your balance. It stops as abruptly as it began, and you walk home. On the way home, you see a flash and hear a whip crack. Lightning has struck a lone tree near where you just stood. It's caught on fire, and there's a column of flames rising to the sky. Still no rain, and the pillar becomes taller and taller. Have you heard of such a thing as a fire tornado? These phenomena occur when the wind is caught in a circle close to the ground because of the difference in air pressure. Such mini tornadoes are usually easy to notice. Small rubble, dust, sand, and leaves rise into the air and start flying in rapid circles. But then, if there's a source of fire nearby, the funnel can catch it and blow it stronger, like bellows. The flames go round and round, reaching ever higher and eventually creating a swirling, blazing tower. Luckily, fire tornadoes are short-lived and don't normally cause much damage. But don't try to hide from the storm under that tree. You can find this unusual plant in Florida and in some parts of the Caribbean coast. Externally, it doesn't look special at all. A gray trunk, green leaves, and fruit similar to small apples. What you must remember is never to pluck these apples and never stand next to the tree, especially if it's raining. This is the manchineel tree, which is considered the most dangerous in the world. Its trunk, bark, branches, and fruit contain poisonous juice. One drop of this corrosive acidic liquid can harm your skin a lot. The tree can secrete this juice, and if you accidentally touch it, you risk burning your hand. When it rains, water droplets fall on the tree and mix with the poison. Water can also bounce off the bark and get on your skin. That's why you shouldn't stand nearby either. There are almost no other shrubs or mushrooms growing around. Animals avoid these trees, and people don't chop them and don't pluck the fruit. You can't make a bonfire from their branches. Burning wood emits poisonous smoke that can damage your eyes. Locals know this tree well, but tourists and travelers might accidentally get harmed. That's why most manchineel trees are marked with paint or have a warning sign. In western Venezuela, locals living close to the Catatumbo River aren't afraid of lightning because they see it almost every single night. It starts at around 7 o'clock and doesn't stop until dawn. The everlasting Catatumbo lightning did once stop for a few months, from January to March 2010. It was probably due to drought, or maybe the charge ran out. In 1991, a scientist suggested that the phenomenon happens because of cold and warm air currents meeting in the area. Another theory is that the lightning could be due to the presence of uranium in the bedrock. Not all lightning happens inside clouds. There's a rare phenomenon called a dirty thunderstorm. The lightning happens above a volcano. The most famous is in Japan. It erupts almost every day and spits black clouds high into the air. So it's super scary volcano clouds plus lightning. Whoa! Regular lightning happens during a storm when ice crystals bump into each other. In a dirty thunderstorm, bits of volcanic ash collide, create friction, and spark up the sky. In the hottest and one of the driest places on Earth, Africa's Danakil Desert, temperatures often rise above 120 degrees Fahrenheit. The out-of-this-world landscape has many active volcanoes and geysers that spit out toxic gases like chlorine and sulfur. The vibrantly green, electric blue, and yellow waters are all rain and seawater warmed up by magma. One wrong step here, and you'd be gone for good. This happened in June 2009. People in certain areas in Japan left their homes after a heavy downpour, only to find fish, frogs, and tadpoles everywhere. Fields, roads, lawns, and rooftops were littered with these aquatic creatures. One man was shocked to see 13 carp on and around his truck. Apparently, he stopped to count them. No one knows for sure where the bizarre rain came from, but the most popular theory claims that a powerful water spout picked up all these creatures. Then it carried them through the upper atmosphere and dropped the animals on the unsuspecting people below. And now, Welcome to Abraham Lake in Canada. It's completely frozen. You step onto the transparent ice and look down at what lies beneath. No fish, just some mysterious frozen bubbles. They look like small clouds frozen in ice, or jellyfish who forgot to pack a winter jacket. There are thousands of these little bubbles made up of methane. But don't try to dig a hole in the ice to touch it. Methane is highly flammable. It's created by methane-producing bacteria that eats leaves, grass, insects, or any other organic stuff that gets into the lake. When the methane touches the frozen water, it turns into tens of thousands of frozen little balls. When the ice melts, they burst open and sizzle. Similar lakes can be found near some shores of the Arctic Ocean. There, the size of the bubbles can reach several times the size of hot air balloons. Beautiful for sure, but not exactly safe. The next shocking lake is in Indonesia, the island of Java. You come to a majestic volcano, overgrown with grass and trees. The volcano seems to be asleep, but smoke is pouring out of it. You climb to the summit. Exhausted, tired, sweaty, you're ready to cool off. Nice work, you made it to the top. You look into the mouth of the volcano. No boiling lava, just a beautiful, bright, turquoise lake down there. It looks like an oasis. Perfect time for a refreshing dip. You run down and get ready to jump in. But that's not water, that's acid! Sulfurous gases get into the lake from under the volcano. The lake itself is full of metals. When the gases touch them, they form that beautiful turquoise water. Acid. Better head back to the nearest village, rest, and come back at night when it's cooler. In the dark, the lake seems to glow. Right above it, you see light-filled, exploding little clouds. The sulfurous gases rise out of the lake, combine with the air, and flash bright blue. Still, don't get too close. The sea turns sinister red, and no living being can survive in it. Must be some dark magic. In fact, it's tiny algae that spread uncontrollably, giving the water this specific tint called the red tide. They have toxins that destroy sea mammals, birds, and turtles, as well as creatures that feed on them. For humans, contact with it ends in breathing problems or seafood poisoning. Sometimes even huge ships sink in the open seas for no visible reason. That reason is often the pockets of bubbles that underwater volcanoes produce even while they're sleeping. Those productive magma factories are hidden under 8,500 feet of water. When they wake up, they act just like land volcanoes, and they can cause destructive tsunamis. This tree looks like a bottle. No wonder it's called the bottle tree. It grows in Namibia and attracts many tourists. But don't get too close to the tree because it's one of the most dangerous on Earth. Milky juice flows inside the trunk. It's highly toxic to the human body. On the bright side though, the trees have beautiful pink-white leaves with a red core. There's a tree growing in Western Australia that was once used as a prison. A cell for criminals existed inside the Boab prison tree for a long time. People were usually kept there temporarily, just for one night. After that, they were taken to their final destination. The prison was built more than 1,500 years ago and has been perfectly preserved to this day. Tourists visiting this place can sneak a peek inside.
When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. So get this. Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So, how did this time warp happen? Well, it's all because of this wonky line. This is the International Dateline. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the new year first? It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west and boom, it's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think that the International Dateline would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 2.5 miles apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 659 miles across the dateline from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it's already Friday. Yep, we're talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Dateline look so ridiculous in the first place? Well, great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, thank goodness, and it takes about 24 hours, or a day, to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Well, basically, people needed to figure out which of these 24 zones or lines would be the starting line, or the chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages just had to wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States with one big goal: to decide on a line that would serve as the official prime meridian. Finally, like it or not, they were determined to create the international date line that the whole world would accept and would follow from that point forward. The prime meridian was established in Greenwich, England, and the international date line was placed on the opposite side, running through the 180th meridian. Well, sounds simple, right? But that's when the nightmare really began. The chosen international date line didn't just wander through uninhabited areas. Oh no! It split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is one day ahead and the other half is one day behind. Take Kiribati, for example. The country is primarily centered in the Gilbert Islands, which sits just west of the international date line. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the date line. Suddenly, Kiribati was straddling the international date line. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. Now, to fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's Day came a day early. Woohoo! After that, the date line moved eastward to go around the entire country. So the same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, well, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit ziggy-zaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international date line, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. Now, in the end, the international date line looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. Now, UTC never changes for daylight savings time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of standard time to make better use of sunlight in the spring and summer and fall evenings. The idea was so brilliant that most countries jumped on board, but not everyone. Just look at Nepal. They have never ever used the daylight savings time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zone. Just like the United States, which has 11 time zones. Australia has 9, while India is a special case. Look, India is a big country with an area that stretches around 1,800 miles from west to east. So it should have 3 time zones in total, but they only have 1. This means that the sun rises almost 90 minutes earlier in Dong in the Far East than in Gujarmoti in the West. And why do they have only 1 time zone? Well, basically, because they can. Just remember that the international dateline and time zones are invisible, artificial, and now you know, totally arbitrary. So if a country wants to stick with just 1 time zone to simplify processes and business operations within its border, then hey, why not? Just recently, our sun unleashed a supermassive solar flare. And it was the most intense one in 7 years. Solar flares are powerful explosions happening within the sun's atmosphere, intense bursts of radiation rising from the surface of our star. How dangerous are they for us? Let's figure it out. Solar flares can indeed affect life on Earth, disrupting everything from power grids to GPS. They can have an impact on spacecraft and astronauts. They produce auroras, painting the sky with vibrant colors near our planet's poles, which is actually not a drawback but a very beautiful view. The most recent flare, part of a series of flares, was classified as an X6.3 event. This classification is based on the X-ray brightness of solar flares. There are 5 classes of solar flares, with A being the weakest and X the most powerful. Each class also has 9 subdivisions, from 1 to 9. The flare in question wasn't as monumental as the flares of September 2017. Those included an X9.3 and an X8.2. And still, it was an awe-inspiring display of energy. The flare stood out as the largest of its kind during the current solar cycle. A solar cycle is a period during which the sun's magnetic field undergoes a complete reversal. One cycle usually lasts for about 11 years. At the moment, we're in cycle 25. It started in 2019 and is likely to last till 2030. The progression of the cycle has an impact on the star's activity levels. The sun is quite tranquil when the activity is minimal, and at solar maximum, this activity reaches its peak. During this period, we can observe lots of solar flares and sunspots, areas where the magnetic field is around 2,500 times stronger than that on Earth and higher than anywhere else on the sun. The particles ejected by solar flares take roughly 2 days to reach our planet. They often ignite auroras. During the most extreme solar events, these auroras can be seen not only close to the poles but also further away. Solar flares and related coronal mass ejections can pose a threat to our world that heavily depends on technology. The problem is that high-speed solar winds emanate from coronal holes. Those are openings in the sun's magnetic field where streams of solar winds rush out of the atmosphere of our star. The plasma in these regions, with coronal holes, is cooler and denser than in other parts of the sun's corona. Insanely fast, solar winds can worsen the situation, impacting our technology and leading to greater disruptions on Earth. You've probably seen headlines like, "Solar storms of 2025, Earth's doomsday is coming." They cause anxiety and panic. Totally unnecessary. It's true that the sun is entering a period of increased activity, which will culminate in July 2025. But these claims about doomsdays, apocalypses, and absolute destruction are not based on scientific facts. Solar storms are just a natural phenomenon, and while they do affect our planet, experts don't expect any catastrophic events to occur even in 2025. Our power grids, communications, and GPS navigation may end up somewhat disrupted. However, the severity of the situation will depend on the direction and strength of the storm. That's what you need to know about the upcoming events. Since solar cycle 25 will most likely peak during that period, there will be more chance of observing solar flares and coronal mass ejections. CMEs. Earth might witness disruptions at different levels. Solar flares will likely interfere with radio communications and GPS navigation. And CMEs, which impact Earth's magnetic field, may trigger geomagnetic storms, potentially leading to power outages and satellite damage. We should be aware of the potential consequences of these cosmic events and take precautions like having backup power sources. But it's crucial to avoid panic. NASA and NOAA, National Oceanic and Atmospheric Administration, regularly provide updates on space weather. They actively monitor the sun, and you can stay informed through reliable sources. Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the Moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under 2 continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the Moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the Sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the Sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed 2 enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges. Ah, beautiful! You're walking with your friend and look up at the sky. The sun looks a bit different today, like it has some kind of ring around it, a rainbow type thing. Huh? Hey, look at that! Your friend pulls his head up out of his phone. You shouldn't look directly into the… Stop everything, he says. It's a sun halo. We need to find shelter now, unless you have the world's biggest umbrella on you. A sun's halo is nature's sign that there's a snow or rainstorm on its way. It's caused by clouds that are made of bazillions of small ice crystals flying around 20,000 feet. Sunlight goes through those crystals, which causes the light to split and refract, like when there's a rainbow. Now, don't look at the sun halo directly. It's going to be tempting because it's not something you see every day. Plus, it's really beautiful. But ultraviolet light can burn the exposed tissue of your retina and cause serious damage. So, not worth it. Grab some sunglasses and you're good to go. This phenomenon lasts about 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many ways. J-shaped trees means there's a landslide coming. Since the ground is moving slowly, the trees grow into the supercell shape. Try to find a flat area and avoid going near any trees, unless you have superhuman strength. You're on a nice walk on the beach. Sand, sun, not a cloud in the sky. Then, out of nowhere, you see the ocean going back away from the shore. Suddenly, you can even see bits of coral, small fish, and other random small sea animals. That's a good sign to leave. There might be a tsunami on the way. A tsunami is formed when there's an earthquake underwater, and it can hit the coast at 500 miles per hour. It's mostly a Pacific Ocean thing, but why risk it? If there's a channel of choppy water on the beach, stay away. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange gap in the waves, or you might notice random bits of seaweed going in all different directions. If you don't ever find yourself caught in a rip current, try to stay afloat and don't waste your energy swimming against the current. Yell out for help and try to float your way along the beach. Once you break out of the channel, swim diagonally to the shore. If you find yourself in the ocean and see a group of sharks swimming, okay, this scenario doesn't sound good either way. Well, the good news is they're not necessarily coming for you. The bad news? The sharks might be trying to escape from a huge tropical storm or even a hurricane. Sharks can sense these things, so when nature gets angry, they group together and swim deep under the surface to get to safety. You probably shouldn't follow them. Good luck! The golden rule since ancient times: follow the animals. Insects, rats, and snakes leave their homes a couple of days before really big earthquakes. Scientists can't track or really explain how they know it's coming. It seems animals really can sense earthquakes, maybe because they feel those smaller initial shock waves that we don't even notice. What if you see animals running towards you? Well, that could mean you're about to get eaten for breakfast. Or it means there's a wildfire behind them. Amphibians like frogs, toads, and salamanders try to protect themselves by burrowing down into the ground. Others just run. Before you start running alongside them, check to see if you can see smoke. You don't want to sprint flat out for nothing. Well, it's not just animals. We can spot warning signs too. For example, if you notice your hair suddenly starts to stand on end and your jewelry starts to buzz, take shelter right away. Lightning might be about to strike somewhere nearby. If you're outside and can't run into a house, make sure not to stand near any tall structures. Lie flat on the ground. Be near water. Seek shelter under an isolated tree or stand in an open space. And don't stand on top of the Empire State Building. That thing gets zapped hundreds of times a year. Do you like skiing? It's all fun and games until all you can see is white. Avalanches can move up to 80 miles an hour, so watch for some warning signs. Does it feel hollow when you walk in the snow? Are there cracks around your feet? Can you see a huge avalanche coming? Time to go! Sometimes a storm mixes its blue light with the red light from the sun, and you get a pretty impressive green. Enjoy it from a safe distance, preferably indoors. This super tall thundercloud usually means you're about to get smashed by hail, or worse, a tornado. Find cover somewhere, like in an underground parking lot or a basement. It might be a bit embarrassing if you're wrong, though. Okay, we know volcanoes can be dangerous, but the lakes near them? Is anything not a sign of danger? Lakes that are near something boiling hot that never cools, so volcanoes, are like wildly shaken soda cans, just about to burst. The magma that's underground actually pushes carbon dioxide into the bottom of the lake, and that gas stays there, waiting. Then, even something boring like rain can disturb the lake a little too much and bam, or boom! You get the picture. Diving, swimming, snorkeling, the sea can be amazing, but it's pretty unpredictable. When two wave currents run into each other, they can create a cross sea. It looks pretty cool from far away, but it can be really dangerous for swimmers, surfers, or even ships. There's a strong current roaming around under the surface. You're walking on the beach, apparently every good story starts like this, and all of a sudden, woo, a cave. How cool is this? You should probably go in there, explore a bit, and no. If there's a full moon out, you might not be able to get out of that cave. A full moon affects the tide and makes it lower than usual. That cave might be more accessible, but instead of an exciting adventure, you could end up trapped in there until the next full moon. Bring a big lunch. A wall cloud is one of those things you're both excited and scared to see. Scared because you don't know what it is. Excited because, well, how often do you see something like that? Whatever you feel, tell your legs to start running. During a thunderstorm, these wall clouds sit lower than anything else and can be up to 5 miles long. And if they start spinning, well, Dorothy ended up in Oz. Who knows where you'll end up? It's 2009 in Italy. A man was hanging out in his kitchen. Then he saw some flickering lights. He knew just what to do. He moved his family to a safe place. A couple of seconds later, a massive earthquake hit the whole region. His family survived thanks to his quick reaction. He knew these flickering lights were actually a sign of an upcoming earthquake. People have been seeing these mysterious lights for ages. Some thought it was some kind of sign coming from space. Scientists never used to take them seriously, but after the invention of photography, more and more evidence of these strange lights appeared. Soon, they realized the connection. The lights appear, and pretty soon, the earthquake hits. After a bit of digging around, they actually found some records of these earthquake lights from hundreds of years ago. There were bluish flames coming out of the ground right before an earthquake. Ooh, creepy. Oh, ocean, come on, not you again. Okay, but just one more. If you see the oceans turned all reddish-brown, don't go in the water or anywhere near it. This red tide is caused by toxic algae and is something you can find all over the world. That toxic algae can be there even if the ocean's a normal color. Getting that stuff all over you can cause some health issues. Rinse yourself off in fresh water as fast as you can. You know, they even wrote a holiday song about it. I'll G home for Christmas. No, really.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the Sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the Sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the Sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, flop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the Sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the Sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst-case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are 2 stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These 2 aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun. So its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun, and if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny.
Tidal locking is when a moon or a planet always shows the same face to another celestial body. I know I do. The moon, for instance, always shows one side to Earth. It doesn't matter if you use binoculars or a telescope, you'll see the same craters and plains every time. This happens with many big moons in space. Take Jupiter's moon, Io, or Saturn's moon, Enceladus. Even Mercury, which rotates 3 times around its axis for every 2 leaps around the Sun, is almost tidally locked to our star. Now here on our planet, the moon's pull creates tides on Earth, making the water rise about a foot. This pull also stretches the moon, making it slightly football-shaped. Many years ago, the moon spun way faster than it does today. This made its protruding parts shift constantly, like the Earth's tides. But the moon's bulges didn't align with Earth's pull. Soon enough, the Earth's gravity pulled them in closer, slowing the moon's spin until it stopped. But if we look at the grand scheme of things, we'll see that our planet isn't tidally locked to the Sun. Earth rotates on its axis, completing one rotation roughly every 24 hours, while orbiting its star. This rotation creates day and night. Lots of things prevent our planet from constantly showing the same face to the Sun. First, Earth's rotation rate isn't perfectly synchronized with its orbit around the star. The presence of the Moon also plays a crucial role. Our satellite's gravitational pull creates tides on Earth, which slightly slows down Earth's rotation over time and balances things out. There's also quite an impressive distance between the Sun and the Earth, 93 million miles. So even if the Sun's gravitational force is intense, it's far enough away to prevent tidal locking. Now, what if space travel gets advanced enough that we end up visiting such a tidally locked planet, one that is constantly trapped between two extremes, eternal darkness and constant sunshine? We can gather some data by figuring out what would happen if the Earth suddenly stopped spinning on its axis. Bad news is, the consequences would be devastating. Right now, we're all moving along with Earth's rotation, even if we don't feel it. If the planet stopped, everything on its surface would be launched eastward. People, buildings, and natural features hurtling sideways at high speeds. Afterward, the remaining high-speed winds, still rotating nearly as fast as the planet, would damage its surface, acting as a cosmic nail file. Even if the slowdown happened gradually, the effects would still be dramatic. The first noticeable change would be the Sun's motion across the sky. Without Earth's rotation, a day would last a half a year. This disruption would throw off our biological rhythms, affecting sleep dynamics and daily activities for many species. Earth's rotation also influences atmospheric patterns, which affect the weather and climate. Air currents would change too, leading to extreme events like desertification or the melting of polar ice caps. Hurricanes, reliant on Earth's rotation to form, would cease to exist. A motionless Earth would likely translate to the loss of our magnetic field, which shields us from harmful cosmic rays and solar storms. Boy, we in trouble now, huh? In the same thought experiment, let's say oceans won't freeze where it's cold or evaporate where it's hot. Because of its spin, there's a centrifugal force that has made our planet a bit wider around its middle. If we measure the Earth around the equator, it's about 13 miles wider than if we measure it from pole to pole. This widening of the solid Earth happened very slowly over billions of years. But the liquid water in the oceans would move more easily. Because of the spin, the water around the equator is about 5 miles higher than it would be on a still planet. If the Earth stopped spinning, the oceans would start moving towards the poles. At first, only some areas around the equator would become land. But eventually, a big continent would form in the middle, like a belt. You could walk around the Earth at the equator without getting wet, even though it would be really cold on one side and really hot on the other. The water that might move away from the equator would end up at the poles. There would be 2 separate oceans around each of these points, with no connection to the equatorial continent. In the north, Canada, Greenland, Asia, and Europe would all be underwater, following a line similar to the border between the US and Canada. But countries like Spain, for instance, would mostly stay above water. Despite these extremes, some say life could still exist in the twilight zone between light and dark. If we could draw it, it would be this softly illuminated region, looking like it's always on the brink of a sunset. This in-between domain could potentially offer the ideal conditions for life, with temperatures balanced between extremes. The planet would end up resembling an eye. Its sunward-facing hemisphere would look like a parched pupil, encircled by a blue-green iris, the place with lots of water and vegetation. Now, it's not all that grim. Since there's liquid water on our planet's surface, sunlight could turn it into clouds that could help us control the temperature should it stop spinning. Also, the way heat moves around in the air could make the climate nicer overall. Winds could carry warmth from the sunny side to the dark side, similar to how ocean currents warm up Europe and cool down Africa. Plus, the way gases move in the air might stop a planet from getting stuck facing one way all the time. Venus, for instance, should be locked in place facing the sun, but its atmosphere helps keep it turning. Our planet might end up pulling a similar trick. Rainfall on a tidally locked planet could further regulate temperatures, especially if there's enough land. On Earth, rain interacts with rocks, trapping carbon and cooling the atmosphere. This process could also help manage carbon dioxide levels. If we were to prepare for a tidally locked world, The Sahara Desert would be a good place to start the boot camp. Located in North Africa, it is the biggest hot desert globally. It covers a vast area from the Atlantic Ocean to the Red Sea and from the Mediterranean Sea to the Sahel region. During the day, the temperatures get really hot, up to 122 degrees Fahrenheit, and at night, it can get as cold as 41 degrees. That is a wide swing. You might stumble upon a sandstorm here and there, but rain is very rare. When it does happen, though, it's intense and can cause flash floods, making the area dangerous. Despite the tough conditions, some animals manage to survive here. One such creature is the Kenneck fox, which is the smallest fox to exist on our planet. It has big ears that help it handle the heat, and its environment stretches from Morocco to Egypt, and even down south to northern Niger and east to Kuwait. It eats whatever birds, insects, and rodents it can find in the sand. As for the coldest place on Earth, data suggests it's located in the eastern Antarctic Plateau. Research indicates that the air temperature there can drop to minus 137 degrees Fahrenheit. Now, if we need to find animals that have adapted well to living in refrigerator with built-in ice maker-like conditions, we just need to look at the emperor penguins. They gather in tight groups, sometimes with huge numbers of these birds, to keep warm. They can't stay in these huddles for too long, though, because they get too hot. Scientists found out in 2015 that it can get as hot as 100 degrees Fahrenheit in the middle of the penguin mosh pit. These birds are the only animals that produce offspring during the Antarctic winter. They travel quite far, somewhere around 50 to 100 miles, to lay just one egg. While the dad keeps the egg warm for about 2 months, mom goes back to the edge of the ice to find food. It's a routine that usually works well, as long as the weather is consistent. Hey, you're running through a vast field at night, as if something is chasing you right now. The light of the full moon brightens your path, and you see a circle of light around it. You run on looking for a safe shelter. It's not about werewolves, who are said to appear when the moon is full. Soon, this place will be the epicenter of a major storm. This very circle around the moon is called a halo, and ice crystals cause it in the sky. When the moon is full, it reflects a lot of sunlight. These rays then pass to the Earth's surface, but they curve their trajectory and split as they pass through hexagonal ice crystals. As a result, we have a halo of different colors, almost like a rainbow. The inner edge of the halo is red and the outer edge is blue. It looks beautiful, but the presence of ice in the clouds means this ice will soon turn into water and begin to fall to the ground. And this rain will be so heavy that you'd better find a shelter beforehand. If the weather is quite warm and the clouds are closer to the ground, you might see a similar phenomenon, a corona. It's much smaller than a halo, but much more colorful. The bluish-white disk on the inside turns brownish-red on the outside. Unlike halo, the corona is made of water droplets. The smaller these drops are, the larger the corona will be. If the water droplets are large, the corona will look like a bright spot the size of the moon itself. Both the corona and halo might also occur during the day when the sun is shining. But be sure to wear sunglasses before just glancing at it, because it's very bright and really bad for your eyes. As soon as you find a shelter, it starts raining heavily. Whoa, what is that? Are you being photographed? No, the flash you just saw is lightning. Bam! Thunder is so strong, the windows in the house start to shake. Here's a tip on how to tell if you're far away from the epicenter of a thunderstorm. When you see lightning, start counting. 1 1,000, 2 1,000, 3, and so on. When you hear the thunder, stop counting. Now you have to divide that number by 5. If you can count to 5, it means the epicenter of the thunderstorm is 1 mile away. If you didn't find a shelter before the thunderstorm started and it caught you in the open, leave the high ground immediately. Any mountain or hill is a high-risk area. Don't even think about hiding under a tree. Tall objects are the first target for lightning. Power poles are also at risk. If a thunderstorm catches you riding a bike, drop it immediately and run away. Same if you were riding in a convertible, golf cart, or motorcycle. If a thunderstorm started while you were in an open field, the tallest object here is you. Get down and try to cover yourself somehow. If you're not alone, try to keep your distance from each other. Whew! Now let's admire the beautiful sunrise. It looks like someone spilled red paint on the sky. This beautiful view means it's about to start raining. You can see a red sky at sunrise because the high pressure zone has just passed you by and is now followed by a low pressure zone with high water content in the air. So take an umbrella with you or go back to a warm bed and stay indoors. There's an old saying to keep it all straight. Red sky in the morning, sailor take warning. Red sky at night, sailor's delight. Sometimes you can even predict rain by smelling it. It's all about ozone molecules. Storm currents bring ozone down from the upper atmosphere, and when the storm is about to start, you can smell a sense of cleanliness. It's like you just washed the floor with clean water. Your sense of smell gets more sensitive before it starts to rain. It's not because of your nose, but because of the more humid air. Flowers spray their scent, and the water molecules stick to it, spreading it much better. That's why the same flowers smell different when you smell them outside or in a closed, humid greenhouse. Plants can also help you predict changes in weather. If you touch the grass in the morning and it's wet, it means it's going to be a clear day. That morning water on the grass is dew. It appears at the coldest time of night. Clear skies allow the earth to cool a bit, and the water vapor molecules in the air turn into a liquid that settles on various surfaces. Take a closer look at the leaves on the trees. Sometimes they can be upside down. For example, maple leaves respond well to increased humidity before the rain. Their stems become very soft, and the wind can turn them upside down. But the best indicator is pine cones. The seeds are inside the cone, just under its scales. The pine needs to keep them as dry as possible so that the wind can carry the seeds far away and new trees can emerge from them. So when the pine senses rain approaching, it gives the order to close the cones. Then the scales close, protecting the seeds from the water. And instead of boring weather forecast hosts, you can just follow the animals and insects. Have you heard the crickets chirp? That will be your thermometer for today. Set the timer for 15 seconds and count how many times crickets chirp. Add 37 to that number and you get the outdoor temperature value in Fahrenheit degrees. All because air temperature directly affects crickets' metabolism. It can chirp slower and faster depending on how warm it is. So throw away your thermometer and get yourself a little friend. Now, if you don't like insects, look up into the sky for birds. If they're flying high, it'll be a clear and sunny day. But before it rains, air pressure prevents birds from flying high. You may see them flying in flocks very low, most likely looking for shelter. So even if the sky is clear, air pressure tells you that rain is coming. If you live near a river or lake, you can hear toads singing, although you can't quite make out the lyrics because it's in toad. They are especially loud before it rains hard. Toads, in general, love wet weather, so they just get excited. Rain is also the best time for females to lay eggs, so they scream loudly in search of a guy to wed. Ow! A mosquito has just bitten you. If mosquitoes are being especially aggressive, you better find a shelter fast. The insects are just trying to eat more before they have to starve during the storm. Also, the warm, humid air makes us sweat more, and we become even more attractive to mosquitoes. Insects also gather in swarms before a thunderstorm. They love the moisture in the air and start circling in a dance. But then they vanish into thin air. It means you have 1 hour left before heavy rain starts. To predict the weather for the next day, you need to watch the bees. If it rains tomorrow, the bees work overtime. They're pollinating flowers actively because they know they won't be able to leave the hive the next day because of the rain. Squirrels can predict the weather for the whole season. They usually stock up on food for the cold times. And if they start doing it early, it's going to be a tough winter. You can see squirrels running around looking for acorns. They hide them in the ground and run to find the next one. The squirrels often forget where they hid their food. These acorns turn into little sprouts, so we have many new trees, all thanks to squirrels. Animals can also predict disasters like earthquakes. Scientists once did a study in an area with frequent earthquakes in Europe. They put trackers on cows, dogs, and sheep. About 18,000 earthquakes occurred there during that time. Most of them were insignificant, but there were also 12 with a magnitude of 4 on the Richter scale. And each time, before the earthquakes, researchers recorded strange animal behavior. It was as if they were trying to escape from the earthquake zone. Scientists believe animals can sense the ionization of the air before a disaster with their fur. Their good sense of smell also allows them to smell gas. It comes from moving deep underground and then trying to find its way out through small cracks in the surface. The first records of such animal behavior date back to ancient Greece. Cats, rats, snakes, and centipedes left their homes and fled to safety days before a major earthquake hit Greece. Some fish can predict the weather in the area. If sharks hang out near the shore, they're not necessarily looking for food. They may be hiding from a big storm at sea. The worst sign on the coastline is when all the water starts to go back abruptly. You can see the entire shoreline and even the fish and coral that are left on the land. Run away immediately, because soon a huge tsunami wave will come here and wash everything away.
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the U.S. was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called Derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle, near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So, a derecho is kind of like a small, average level 1 to 2 tornado. Usually, its speed is within the range of 73 to 113 miles per hour. And, in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day, when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, scientists don't have an exact explanation. But although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen. Look at this ominous dark cloud. Is it rotating? What on earth is happening here? What you see is called a supercell. It's a storm, often a thunderstorm, that contains an updraft rotating about a vertical axis. That's why they're also called rotating thunderstorms. There are actually 4 types of thunderstorms: single cell, multi-cell, squall line, and supercell. Out of them all, supercells are the rarest and the most severe. They're typically isolated from other thunderstorms and last for 2 to 4 hours. Supercells are very common for the Great Plains of the United States, in particular, the area known as Tornado Alley. But they can occur in other parts of the world too. For example, in Europe, Argentina, Uruguay, and southern Brazil. These storms can be any size, large and small, high or low topped. Supercells are also associated with the most severe tornadoes, even though not every supercell can create one. These storms usually produce great amounts of torrential rainfall and hail, and are accompanied by powerful winds and downbursts. Downbursts are powerful winds that come down from a thunderstorm. Once they hit the ground, they spread out very quickly. These winds are dangerous since they can cause a lot of damage. Even though they're often confused with tornadoes, downbursts are a totally different phenomenon. Let's have a look at how a downburst forms. At the beginning of a thunderstorm, there's a powerful updraft. That's why the cloud grows vertically, and hailstones and raindrops start forming inside. The storm matures, and the updraft keeps feeding the cloud with unstable, moist air. Hailstones and raindrops are now big and heavy enough to fall to the ground. But sometimes, the updraft is so strong that it suspends huge amounts of hail and rain in the upper part and the center of the storm. But let's say some dry air gets into the middle and lower parts of the storm. It can cause a downburst. When it happens, all that amount of rain and hail from the upper part of the storm dashes toward the ground, dragging along a lot of air. All this mass gains speed, and when the downburst eventually reaches the ground, it's like a stream of water coming out of a faucet and hitting the sink. It spreads in all directions at an incredible speed, sometimes more than 100 miles per hour. But what you might most likely come across is called a microburst. It means that those terrible winds are confined to an area smaller than 2.5 miles across. While speaking about tornadoes, I can't but mention volcanic tornadoes. They're possibly one of the scariest natural phenomena. When a volcano erupts, it throws hot rock and ash high into the atmosphere. As for lava pieces and hot gases, they travel down the volcano's slope. When this flow is moving down, some of the gases trapped inside begin to rise and spin at the same time. They get squeezed by the surrounding air, which makes them spin faster and faster. That's how a volcanic tornado gets born. On the bright side, this phenomenon has a very short lifespan. If you ever see a tight burning column of air, that's a fire tornado, a creepy combination of whirlwind sounds and scorching inferno. This phenomenon is also called a fire twister or fire whirl. This dangerous natural phenomenon mostly occurs during wildfires. While burning, such fires create a big area of boiling hot air just above the ground. And when this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenados can stretch hundreds of feet into the sky. Another dangerous natural phenomenon is called a snow squall. If you get caught in a snow squall while driving, you won't find a safe place on a highway, because this is an intense, but thankfully pretty short, period of heavy snowfall that comes along with powerful gusty winds, and sometimes even lightning. People have known about this phenomenon for quite some time, but the term itself, as well as the warning associated with this danger, appeared only in 2018. Another danger of snow squalls is something called a flash freeze. Come to think of it, it makes sense. Rapidly dropping temperatures and freshly fallen snow glaze highways very fast. This makes controlling your car almost impossible. The next curious phenomenon I'm going to talk about happens extremely rarely and is still poorly understood. It's usually not something big and turbulent. Dust devils can be tiny and vanish within minutes. They've got lots of names: whirlwinds, dusters, and sand spouts. Dust devils look like funnels of sand spiraling upward from the ground. But unlike their terrifying relatives, tornadoes, these babies are normally nothing to worry about. And still, according to the definition, dust devils fall in the same category as hurricanes and tornadoes. All three natural phenomena feature a column of air kind of spinning around an invisible pole. They're all formed during the collision of different types of air, moist versus dry, or hot versus cold, and so on. But hurricanes usually form over a body of water where cold air slides under warm air. Tornadoes spiral down from the sky when hot air rises through a mass of cold air, and dust devils form on the ground. Even though we call them dust devils, they can actually swirl any loose debris. The main criteria: the pieces have to be small and light enough to be lifted by a fast-moving vortex. By the way, do you know that some clouds can predict extreme weather? For example, shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft. These ominous clouds most often mean a storm is coming. Those huge white lumps over your head are called mammatus clouds. They can make you believe the sky is falling. Most clouds form when air rises into the atmosphere, but mammatus clouds appear when moist and cool air goes down and mixes with dry air. The result is these unique puffed rice clouds. By the way, if you see this phenomenon in the sky, bad weather is just around the corner. Morning glory clouds are extremely rare and harmless. They look like massive tubes stretching across the sky. They can snake for more than 600 miles, sitting relatively low. Most researchers agree that these clouds appear when an updraft squeezes through the cloud. This creates the signature rolling appearance. The cool air at the back of the cloud makes it sink downward. The best, but not the only, place to see the morning glory is Australia's Gulf of Carpentaria. If you decide to travel there to see these clouds, choose a period from late September to early November. Ever seen huge round disks in the sky? Most likely, those were lenticular clouds. They usually form over large and high places, like mountains or hills. When strong wind bumps into some barrier, this creates an air wave. The air kind of wraps around the obstacle, and the higher the barrier is, the colder the air that is rising over it becomes. At some point, the moisture it contains turns into water droplets, and they form these unusual clouds. Lenticular clouds can look like waves, a pizza, or even a stack of pancakes. And these clouds, on the contrary, form low in the sky and after some bad weather. Rainbow clouds appear on top of puffy low-altitude clouds after thunderstorms. They usually hover at the height of around 6,000 feet. When the water vapor they contain condenses, the resulting droplets act like prisms. This forms multicolored caps over the clouds. And a pretty scary bonus fact for you. One of the most common causes of wildfires is lightning from thunderstorms. But have you ever heard of a wildfire that triggered a thunderstorm? Well, now you know. It happened on May 11, 2018, not far from Amarillo, Texas. Then, the super powerful Mallard Fire not only created a massive dense cloud high in the air, but its heat also caused a violent thunderstorm that later dumped tons of quarter-sized hailstones 60 miles away in Wheeler County, Texas.
I'm about to introduce you to a place where the laws of physics take a vacation. Welcome to the mystery spot, where you can witness all kinds of implausible things that will leave you scratching your head in disbelief. Don't worry, it's not sorcery or witchcraft. It's just some clever optical illusions that mess with your brain and make you question reality. Back in the day when the Great Depression was hitting hard, people needed some fun distractions. That's how the entertainment industry gave birth to the concept of mystery spots. One of the most famous mystery spots is the one near Santa Cruz, California. The name is all intrigue and mystique, isn't it? Once you step inside, you'll see people standing upright on a slanted floor or at impossible angles on a flat surface. You'll see a ball rolling up a ramp, defying gravity and logic. It's like being in a fun house, but without creepy clowns. The site is known for its gravity-defying demonstrations, which appear to bend the laws of physics, both on the short uphill walk and inside the wooden building on the site. Misperceptions of the height and orientation of objects occur here. These visual illusions include balls rolling uphill and people leaning farther than normally possible without falling down. Psychologists at Berkeley state that all of the misperceptions stem from the simple fact that the house is slanted at a 20-degree angle. The next stop is again in the USA, but this time at Hoover Dam in Nevada. Here, gravity seems to play with us too. Try this experiment if you ever happen to go there. Pour water from a bottle over the dam. You will witness that instead of going down, the water will start flowing upward. The reason behind this is a very powerful updraft that the structure of the dam creates. In other words, the water gets carried upward by the wind. This trick is not unique to the dam, as there's a reverse waterfall in the Faroe Islands. It occurs due to a wild weather phenomenon known as an inverted waterfall. Imagine a gigantic whirlwind of ocean spray swirling up a steep, 1,542-foot high rocky cliff. So how does this crazy phenomenon happen, you ask? Well, it's all thanks to a spiral column of air that rotates near high and steep cliffs, creating a mini tornado effect. And when the wind hits the edge of the cliff, it gets even stronger and picks up coastal water, which then splashes up the cliff and creates a massive water and wind funnel. Apparently, these inverted waterfalls can happen in other places too, like on the cliffs of Moher in Ireland, the mountains of Iceland, and even in the Waipuhia Falls of Hawaii. Talk about Mother Nature showing off her skills. Magnetic Hill in Ladakh, India? The ultimate mind-bending road trip destination? Here, you can watch objects and cars roll uphill like they're stuck in some kind of magnetic vortex. It's an optical illusion that occurs thanks to the sneaky slopes and general layout of the area. The road might look like it's going uphill, but it's actually a downhill road in disguise, playing tricks on your brain like a mischievous magician. You might also see your car moving by itself in the neutral gear. No, your car isn't haunted. It's just basic physics at work. Even when the engine is off, the wheels can still turn, thanks to momentum and the subtle slope of the road. Mount Aragats has a similar story to the Magnetic Hill of India. This one, too, is like a magnet for thrill seekers and car enthusiasts. It's located on the border between Turkey and Armenia. It has a reputation for making cars defy gravity. People from all over the world visit this mountain to witness the incredible spectacle, where a car parked on the slope seems to roll uphill all by itself without any driver behind the wheel. There's a nearby river that flows uphill too. People who visited this site claim that it's easier to go up than down there. Number 6 on the list is the Golden Boulder from Myanmar. The rock looks like it's about to tumble down the hill at any moment. But it's not going anywhere. It's been sitting there for over 2,500 years. The rock is the centerpiece of a stunning pagoda that sits on top of it, towering 49 feet above the ground. According to legend, the rock is held in place by none other than a strand of Buddha's hair. It's no wonder that this place is one of the most important Buddhist pilgrimage sites in Myanmar. The rock was chosen by a celestial king who was impressed by a Buddhist monk's incredible asceticism. So, he used his supernatural powers to carefully place the rock in its current spot, where it looked like the monk's head. If that's not enough, it's said that only a woman can move the boulder. That's why women aren't allowed to touch it. So, if you're up for an adventure, head over to this magnificent rock and pagoda and witness this gravity-defying feat for yourself. Back to the US. Oregon Vortex is located on Sardine Creek, Oregon. It's a tourist attraction that's been around since 1930. The owners of the attraction claim that it's some paranormal activity, but it's pretty obvious some clever optical illusions are involved. Legend has it that even before the attraction was built, Native Americans in the area warned that this land was forbidden, and horses refused to go there. But then, some gold miners built an assay office there in 1904, and the building ended up sliding to a wonky angle. Now picture this. You're in a cozy spot, away from city light pollution, staring up at billions of stars putting on a sparkling show above you. But if you're lucky enough to be in Marfa, Texas, you'll get a little something extra. Mysterious orbs decide to join in on the fun, shining bright like a diamond, and they've been doing it for over 100 years. But what are these glowing orbs called Marfa lights. Well, everyone has their own theories. Some people think they're just car lights from the nearby highway, but that's no fun. Others believe that these orbs are actually sentient beings trying to convey some sort of important message to us, mere mortals. Imagine standing at the edge of a stunning lake, admiring the picturesque view of a majestic volcano. Suddenly, you hear a loud boom and flames shoot up into the air like a fireworks show gone wild. But don't worry, it's not an eruption, it's just the Kauai'an Lake and volcano doing its thing. This fiery spectacle is caused by a natural phenomenon where sulfuric gases burst through the rocks and ignite upon contact with the outside air. The result? Flames that soar up to 16 feet in height, burning blue like the coolest neon lights you've ever seen. And if that's not enough, the liquid sulfur that streams down the mountain looks like a molten river of electric blue lava. It's equal parts terrifying and breathtaking, and a sight you won't soon forget. Speaking of unforgettable things, the Richat structure in Mauritania has been an eye-catching enigma for astronauts since the dawn of the NASA space program. This circular feature in Earth's crust was created by a raised dome that was eroded over time, revealing the original flat rock layers. As you move from the center of the structure outward, you travel back in time, as the older rock layers are exposed in the middle. This geological phenomenon is made up of sedimentary and igneous rocks and measures 28 miles across. From space, you can see several faults where the rock layers have shifted and have been pulled apart. The Richat structure is situated in the heart of the Sahara Desert. There you go. This is our version of the top 10. Would you add something else to this list? You might not think about gravity much, but it affects everything we do. It's the reason why things fall down instead of flying up. It keeps us connected to the Earth, so we don't float away into space when we jump. But for physicists, gravity is something more. It's a fascinating puzzle that needs to be solved to understand how the universe works, and they're on a quest to uncover its secrets. So what's so mysterious about it? Let's see. We've learned a lot about gravity from the legendary Isaac Newton. He was the first to invent the law of gravitation. He taught us that any two objects in the universe can't help but be attracted to each other. It's like they have this secret gravitational crush going on. How strong this attraction is depends on two things. How big the objects are, that is their mass, and how close they are to each other. But here's where it gets cool. Gravity isn't just a two-object dance. It's a complex space choreography. Take our solar system, for example. The sun plays the lead role, using its gravitational pull to keep all the planets in their orbits. But each planet also has its own gravitational mojo, tugging at the sun and even its neighboring planets. Then, a few hundred years later, another hero, Albert Einstein, took gravity to a whole new level. He described the theory of general relativity. According to Einstein, gravity isn't just a regular force. In reality, it's curving and warping the fabric of space-time. Think of it as a heavyweight champion sitting on a rubber sheet. The sheet bends and curves under the weight, and the smaller objects nearby can't help but roll towards the heavyweight. Now, even though we can't see space's curves with our own eyes, we can see what happens to objects that get caught in its grasp. Getting pulled by gravity is like being caught in a whirlwind of forces. The caught object starts spiraling downward, just like a coin in those penny slot cyclone machines you find at tourist shops. Or it might move gracefully in circles, like bicycles racing around a velodrome track. Gravity is the primordial force that guides our entire world. Without it, there would be no stars, no galaxies, nothing. But where does it come from? Well, that's the million-dollar question. And we don't have a complete answer just yet. But we do have some guesses. First of all, we know that gravity is more than just a feature of space. It's a force that pulls things together. Surprisingly, it's the weakest force among them all. But let's take a different look at gravity. Something that may surprise you. Instead of being a force that directly pushes or pulls objects from a distance, it's more like a dance. Gravity, as amazing as it is, doesn't perform alone in this dance. It shares the spotlight with other forces, like electromagnetism, for example. Let's imagine two electrons. There are dancers. Now, they don't directly push or pull each other like you might expect. Instead, one electron creates a special kind of field around itself, like an invisible force field. This field sets the stage for the show. The other electron senses this field and starts to twirl and interact with it. It's like they're following some choreography. And when we watch this dance, it looks as if the second electron is being pushed or pulled by the first one. But in reality, it's all about the intricate movements and interplay between the dancers and the field they're dancing in. The dancers never touch each other directly, but their interactions through these fields make it seem like they're connected. It's a magical display of fields and movements coming together to create the illusion of forces at play. The thing we call gravity. So even though it's not a force in the usual way, it behaves like one. We call it an emergent force, because it emerges or comes out from the way space and objects interact. Which is why, if we want to get technical, some scientists prefer to avoid the words gravitational force and opt for the term interaction. It's just a way for particles to mingle and exchange energy and information. Electromagnetic interactions, gravitational interactions, they're all part of this grand soiree. At least that's one of the theories. Some scientists also think that gravity might be made up of tiny particles called gravitons. These sneaky particles work behind the scenes, making objects attract each other. However, we haven't been able to directly see these elusive gravitons yet. So, according to this theory, gravity is both a force and a potential particle. As you can see, we have some struggles with explaining how gravity works on a large scale. But at least we have a good understanding of how it behaves in certain situations, like how planets orbit the sun, or how objects fall to the ground and stuff. But what happens when we zoom into the atomic scale? And what if we venture into the depths of black holes and the Big Bang? Now here's where gravity's wild ride goes off the rails. First, let's enter the realm of quantum mechanics. There's something peculiar that happens in this tiny world. Gravity, the force that pulls things together, seems to take a back seat. On a microscopic scale, other forces like electromagnetism take the spotlight and become the superstars. They're overshadowing gravity, and this leaves scientists scratching their heads, wondering, is this possible? Why does gravity suddenly fade away? So far, we have no idea. And when it comes to the grandest scales, where immense objects like black holes, gravity takes on a whole new level of complexity. For example, inside a black hole, laws of physics and gravity, as we know them, basically fall apart. It also decays when we try to understand how gravity behaved immediately after the Big Bang. Where did it even come from? We have no idea. In other words, we find ourselves in a cosmic fog when it comes to understanding gravity. But fear not, scientists are working hard to learn more about this enigmatic emergent force. They're doing all sorts of experiments and using fancy technology to crack its code. Even though we still have a lot to figure out, we're making progress every day. For example, have you ever heard of gravitational lensing? It's like a mesmerizing magic trick. Imagine a beam of light as a fearless explorer, taking a straight path through the universe. But as it encounters the gravitational pull of a massive object, the light's journey becomes a wild roller coaster ride. The gravity of the massive object bends the fabric of space-time, creating a funhouse mirror effect. Our brave beam of light finds itself curving and twisting around the massive object, following a new unexpected path. But as the light changes its trajectory, it also reveals to us distant and hidden wonders that would have remained invisible otherwise. The light can magnify, distort, or even create multiple images of faraway objects. So all the things that have been playing hide and seek with us finally become visible, like black holes. There's also a mind-blowing idea called gravitational waves. Einstein predicted their existence tens of years ago, but only recently have we finally been able to confirm them. And that was a huge breakthrough in the science world. These waves carry the echoes of cataclysmic cosmic events, such as the collision of massive black holes or the birth of newborn stars. Just like dropping a pebble into a serene pond, these crazy events cause a ripple effect. But instead of water, it's space-time itself that ripples and warps. Scientists have just recently developed a way to listen to these whispers. They've created instruments capable of detecting these gravitational waves. These instruments, known as interferometers, are like ears that are finely tuned to catch the subtle vibrations of the universe. But one thing's for sure. Gravity is a superstar that shapes our universe. It keeps everything around us connected and rules our entire universe. The quest to unveil its ultimate secrets continues, and it's a thrilling adventure for scientists and curious minds alike.
You decide to go out for a morning jog for the first time in your life. You put on your headphones and get ready for something hard and unpleasant. But as soon as you go outside, you feel an extraordinary lightness. At first, you enjoy it and speed up, but then you realize that something's wrong. You're running too fast and too easily. You feel like you've just taken off a heavy backpack that you've been carrying all your life. You're so fast, you think you must have a superpower now. But you notice another athlete running as quickly as you. You notice a puddle ahead of you and jump over it. You jump so far and so high, it feels physically impossible. You fall to the ground, shocked. Then you notice there are no scratches on your body, and the ground feels lighter. You stop the music in your headphones and turn on the radio. All the news reports say the gravity on the entire planet has decreased by half. Thanks to gravity, we stand on the ground and don't fly away into the sky. This power allows our planet to revolve around the sun and the moon to revolve around us. Heavy things seem heavy because of gravity. And now, something has happened to the Earth's core, and the mass of our planet has decreased. This is the reason for the change in gravity. People happily run out of their houses and jump twice as high and further than they used to. Any objects seem twice as light to you. Your body has become lighter, so you can easily stand on your hands. But still, you don't feel like a superhero. You can't lift a car, even if its weight was reduced by half. But now, parkour is easier for everyone than before. Your body's weight has decreased, which means you get less damage when you fall. However, panic quickly replaces the joy of the new conditions. It becomes hard for you to breathe, the same as all other people. The air has become lighter. The updated force of gravity has reduced the air pressure by half. Now you feel like you're at an altitude of 16,500 feet among the streets of a usual town. It's like you're halfway to the top of Mount Everest. The air is no longer as dense, and the main part of it has settled in the atmosphere. In the beginning, everyone experiences massive dizziness and panic. You feel like there's not enough air in your lungs, so you get nervous. To solve this problem, you have to learn to breathe slowly and evenly. Thanks to this, you calm down a bit. Others also learn to be more balanced and don't live in a hurry anymore. All of you experience less stress and enjoy every day. Then scientists create unique oxygen masks. You put it on, take a breath, and a special filter puts pressure on the oxygen molecules, making the air denser. After a couple of decades, people will take off these masks as they'll ultimately get used to the new conditions. New generations will be born with adapted lungs. The Earth's atmosphere is expanding. It seems the sky has risen higher and acquired a darkish hue. Satellites flying around the Earth's orbit are now inside our atmosphere, but the Earth's gravity still attracts them. You see thousands of satellites burning up. Some of the space debris survives the atmospheric shield and falls to the ground. A meteor shower begins. Space trash crashes into houses, roads, trees, and cars. You and the rest of the people decide to wait out the storm underground, in the subway or basements. Fortunately, the shower doesn't last long. People come out of their hiding and look at the sky in surprise. The moon changes its previous position and slowly flies away. Soon it disappears completely. Our planet is now like a heavy ball in the center of a huge blanket. That blanket is gravity. It bends under the ball's weight. If you put any light object on the blanket, it will roll down to Earth. But if an object is moving at high speed, it will be able to spin on the blanket's edge and not fall into the center. Thanks to such speed, the moon doesn't fall on us, but at the same time, it can't fly away. Now that gravity has decreased, the blanket has become twice as loose. The rotation speed allows the moon to fly out of our gravitational field. It just goes into space. People will be able to observe the wandering moon for a long time through telescopes. Meteorites might crash into it. It could also find another planet with stronger gravity and will revolve around this new home. The moon may stay in place, but will be revolving around the Earth at a slower speed. In any case, there will be no more tides on our planet, and the sea level will remain the same. In the sea, you can also feel the changes. It's much easier for you to stay on the water, and you can swim faster. But the coolest thing is running along the shore. The splashes are floating in different directions, so slowly and beautifully. The waves are running on the sand in slow motion too. The weight of cars, planes, and ships has reduced, and so people consume less gas now. You can drive twice as far with a full tank. Fuel transportation is easier, and less energy is spent on flights. Gasoline is becoming cheaper. The decrease in gravity inspires space tourism development. It becomes much easier for people to fly out of the Earth's orbit. Winter has come. You're walking down the street during a snowfall. It seems to you the snowflakes are stuck in the air as they're so slow. You step on the ice and realize that it's almost impossible to walk on such a slippery surface. Your weight has decreased, and the pressure of your feet on the ice is twice as weak. You're sliding and can't stop. You often fall, but you don't feel any harm. When the wind is strong, it's hard to stay on your feet. If you jump, you may even fly away. The grip of wheels on the road deteriorates. A driver can no longer brake abruptly. The wheels don't spin, but the car continues to slide for a while. That's why new speed limits are being introduced all over the world. You can still enjoy extraordinary strength and long jumps, but after a few generations, the human body will evolve and fully adapt to these conditions. People and animals will be born taller and bulkier. Majestic tigers the size of a truck are walking through the city streets. Flamingos the size of a plane are flying in the dark blue sky. But the worst thing is that the size of insects has increased too. A regular cockroach can now grow to be the size of a computer mouse, and tarantulas become twice the size of an adult palm. At the same time, all living beings become lighter in weight. Humans will become elegant and agile creatures. Our bones and muscles will stretch. The structure of the entire human body will change. We'll become thinner and smoother. Blood in the veins and vessels will flow more slowly, and it will greatly impair the brain's work, but only in the beginning. In the future, the body will expand. The brain will increase, as will the number of neural connections inside. The lungs will become more sensitive and spacious. People will be smarter and wiser. All devices and materials will be developed according to the new conditions. A cup, a pencil, a plate, phones, and other gadgets. Everything will get lighter and more fragile. If an ordinary person gets into such a world, they'll feel like a superhero. You'll be able to punch through lightweight walls and doors and break bricks with your hand. New people won't match your power, but you'll seem too small and clumsy to them.
It's normal for planets to be a bit tilted on the side. The Earth is tilted at a 23-degree angle. That's why we have seasons. It's summer when the part of the world where you are leans closer to the sun. It works the opposite way too. It's winter when you lean away from it. But Uranus is tilted more than normal. It lies as a 98-degree angle, which has a huge effect on its seasons. Each season on Uranus takes 21 years to play out. Something to think about the next time we complain that winter lasts forever. Now, here on Earth, we measure distances in minutes and hours, maybe even days. It takes 10 minutes to walk to your best friend's house, or 15 minutes to drive to your favorite cafe. But in space, it's different. It's vast, which means we measure how long it takes to get to a certain point in years, or in most cases, light years. So, if you want to walk to the moon one day, that would take you 9 years to span the 239,000 miles. Perhaps you'd like to take a ride to the nearby star, Proxima Centauri. Maybe if you kept the pedal to the metal at a constant speed of 70 miles per hour, you'd get there in about 356 billion hours, or around 40.5 million years. Trust me, after the first 20 million years, you'd be second-guessing yourself as to why go there in the first place. Now, Mars contains the biggest valley, Valles Marineris, we've discovered so far. It's a pretty impressive system of canyons, 2,500 miles long. That's 5 times longer than the Grand Canyon. Researchers first spotted it back in the 1970s. A bank of volcanoes located on the other side of the canyon ridge probably helped form this valley. We haven't discovered a planet completely made of diamonds yet, but on some planets, it actually rains diamonds. On Jupiter and Saturn, gas giants of our solar system, lightning storms turn abundant methane into soot, which we also know as carbon. The soot falls and transforms into graphite. Further graphite transforms into diamonds with a diameter of about 0.4 inches. Now, before you start figuring out how to book a diamond collecting field trip, know that these diamonds don't last. After they enter the planet's core, they melt. Ever notice how when you're stargazing 2 nights in a row in the same time, let's say 9 p.m., the stars stay in the same place, but the moon doesn't? Well, there are 2 reasons for that. First, it depends on what time you go stargazing. For instance, if you go outside at 8 p.m. and tomorrow you look for it at 11 p.m., you'll see the moon in 2 pretty different places. In this case, even the stars take different places in the sky since our planet is spinning. As you know, it takes 24 hours for it to make one full circle. That means, from our point of view, it seems like both the sky and everything up there is just moving around us one time per 24 hours. In the same way, the sun changes its position, rising and setting every day. So, if you went outside 2 nights in a row at the same hour, in most cases, you'll have to wait for an extra half hour or more until the moon gets back to the same position as the night before. The stars are pretty much standing still. It seems like they're moving, but that's because the Earth is spinning. But the moon is actually moving around our planet and goes through different phases. For example, a new moon is when it's completely dark in the sky. A full moon is when its day side is facing the Earth. It takes approximately a month for it to finish one circle around the Earth. Maybe you'd be luckier on a diamond collecting expedition on this next planet, 40 million light-years away from Earth. Scientists used to call it a super-Earth. Now, a super-Earth is generally a planet way bigger than ours. This planet, for example, is double the Earth's size. It's so close to its star that it makes a full circle around it in less than 18 hours, which means a year there is pretty short. Since it's so close to its star, its temperature goes up a whopping 4,900 degrees Fahrenheit. Because of the heat, in combination with the planet's density, scientists have the theory that its core is made of carbon in the form of graphite and diamonds. Over 10 years ago, astronomers discovered a huge water vapor cloud. It was 12 billion light-years from our home planet. That cloud is the biggest source of water we know of. It's also the oldest, dating back to when the universe was only 1.6 billion years old. Now it's 13.8 billion years old. Man, if only I had started a savings account 12 billion years ago. With compound interest, I'd have me quite a pile of cash by now, but I wasn't around then. Anyway, this cloud is so large it holds 140 trillion times the amount of water in all the oceans on our planet. This cloud kind of feeds a black hole. It may also contain enough gases, such as carbon monoxide, to encourage the black hole to grow 6 times bigger than it is at the moment. The average temperature of our planet is about 57 degrees Fahrenheit, and the highest temperature ever measured was 134 degrees. Sound too hot? Well, on Venus, it can go up to 900 degrees, which makes it the hottest planet in our solar system. It's not hot enough to melt steel, though. It would need to be higher by 2,500 degrees to get there. But it's hot enough to melt lead, and it's way too hot to sustain life, at least not in any form that we know. Venus is not even the closest to the Sun, it's Mercury, but it has a super thick atmosphere that traps greenhouse gases. It's like you covering yourself with a pretty thick blanket in the middle of the summer. Now, we're used to seeing volcanoes spewing hot molten lava. After all, that's what they mostly do on Earth. But in space, volcanoes tend to spew methane, water, or ammonia. And these materials freeze as they erupt and eventually transform into frozen vapor and something called volcanic snow. I'm talking about cryovolcanoes here. You can find them on Jupiter's moons Io and Europa, Saturn's moon Titan, and Pluto. These volcanoes are especially active on Io, which has hundreds of vents. NASA vehicles have even captured some of these erupting in real time. Plumes of frozen vapor coming out of them extended for about 250 miles. Hey, by the way, they just discovered another moon around Jupiter that might actually be good for farming someday. It's named EIEIO. Now, what exactly happens to the light after it disappears inside of a black hole? Well, photon is a particle of light. The event horizon is the boundary of a black hole. When something, say a photon, crosses the line and enters those boundaries, it can't escape anymore. But it doesn't mean a black hole destroyed it. It pulls the photon in rapidly towards its center, where an enormous mass is packed into an infinitely small space. But we're not sure what happens to photons in such extreme conditions. It's still one of the biggest mysteries. Does a black hole destroy the light or not? Saturn has 82 moons we know about, 53 confirmed and 29 more that are still on the waiting list to be confirmed as actual moons before they get their official names. And one of the coolest moons might be a 914-mile-wide hunk of rock called Iapetus. It's dark on one side and bright on the other. Its lighter half is 20 times more reflective than the other one. As it turned out, the bright side is ice. The dark side is a bit more complicated. One theory says it's dark because of particles coming from another moon, the one named Phoebe. Another theory says it could be because of heat. Since the moon is rotating really slowly, its dark material is absorbing heat, which makes it even darker. Now, how big do you think a black hole can become? In theory, we can't find an upper limit to its mass, but astronomers believe the ultramassive black holes, or UMBHs, located in the cores of certain galaxies are mostly up to 10 billion solar masses big. Recently, they even discovered these UMBHs physically can't grow much more than this, because, in that case, they would start to disrupt the accretion disks that feed them. That way, they would kind of stuff the source of new material. Most people picture the universe as somewhere between aquamarine and pale turquoise. Even some researchers thought that was the case. They managed to determine the cosmic color by combining light from more than 200,000 galaxies within 2 billion light-years of our planet. But the real color is actually closer to beige. Researchers got it all wrong because there was a bug in the software. No, really? It converted the cosmic spectrum into the color our eyes would see if we were exposed to it. The team defined this color as a cosmic latte. Ooh, make that a double-shot low-fat large to go, please.
People stop their cars on the highway, get out of them, and lift their heads in wonder. In the cities, everyone takes to the streets. Balconies and rooftops of houses are full of people staring at the moon in shock. It's red. Some people scream that it's the end of the world. Some seek shelter. Indeed, the usual white moon now looks like it's been doused in red paint. There's no need to be afraid if you see such a thing. On the contrary, enjoy the view, because you have witnessed a rare astronomical phenomenon. This is a total lunar eclipse. Here's the sun. It's in the center of our solar system. Mercury, Venus, and here's Earth and the moon. The Earth takes 365 days to orbit around the star. At the same time, the moon revolves around the Earth and completely orbits our planet in 27 days. The Earth creates a shadow zone, and sometimes the moon passes through it. The shadow is cone-shaped and gradually narrows. The moon is 238,000 miles away. That's like 9 lengths of the equator. At this distance, the width of the shadow is about 2.6 times the width of the moon. When the moon is in this zone, direct sunlight doesn't reach it. That is, it should have disappeared, but instead, it becomes red. All because the sun's rays pass through the Earth's atmosphere. They scatter, and most of the blue light disappears. But the red and orange rays continue and hit the surface of the moon. Voila! You see a phenomenon called the blood moon. By the way, this curvature of light occurs at sunsets and dawns. The atmosphere scatters the blue light, and you see a red and orange sky. If you were standing on the surface of the moon during a total lunar eclipse, planet Earth would be exactly between you and the sun. So, you would be able to observe the solar eclipse. The surface of the Earth would become entirely dark for you. All you'd see would be the sun's corona illuminating the edges of the planet. The Earth from the surface of the moon is almost the same size as the moon from the surface of the Earth. Such a red eclipse of the moon is rare because several factors must coincide. One of them is that the moon must be full. Usually, you can see 2 total lunar eclipses a year. In 2038, you'll be able to see 4 such eclipses, and the eclipse itself can last up to 108 minutes. But this is rare, and the last time such a long blood moon was seen was in 2000. Many years ago, people didn't know so many facts about our satellite, and the sight of a red moon frightened them. It was a bad sign and a harbinger of trouble. People who knew the schedule of eclipses could take advantage of it. For example, Christopher Columbus had an astronomical almanac and knew when the next lunar eclipse would occur. He frightened the inhabitants of the Caribbean islands when he predicted the red moon. Once upon a time, the moon used to be a red ball of lava. This was way back in time, 4.5 billion years ago. Now this is our solar system. It's full of dust and asteroids. They're constantly bumping into each other, playing space billiards. This is Earth. It's just beginning to cool off from the constant asteroid and comet impacts. But then, Theia appears on the horizon, a planet the size of Mars. It had a chaotic orbit and was approaching Earth in a spiral. A collision was inevitable, and at one point, one of the biggest crashes in our solar system occurred. Theia struck the Earth at an angle. It ripped out part of the Earth's crust and threw it into space. The Earth, in turn, absorbed part of the planet that rammed it. The debris from the collision circled the Earth for a long time. They were a kind of ring, almost like Saturn's. Debris in orbit collided and piled up around a common center of gravity. And that's how the Earth got the moon. There's a theory that this collision helped give birth to life on our planet. Theia hit the Earth at a perfect angle. If the crash had been head-on, both planets would likely have been destroyed in a massive explosion. If the impact had been tangential, then there wouldn't have been enough debris in Earth's orbit to form the moon. But we got the lucky ticket. The moon stabilized the Earth's rotation. The collision shattered the planet's solid crust and allowed oceans to form. Remember, water is the basis of life. When the cores of Earth and Theia merged, we got a powerful magnetosphere. This protects all living organisms from solar radiation. The moon, along with the sun, controls the tides. Its gravity seems to draw water to it from the Earth's surface. The sun does the same thing. That is, if we imagine the Earth as a ball of water, there would be two mountains, one on the moon's side and one on the sun's side. And as the moon moves around the Earth, this mountain of water moves with it. If you were in the open ocean with a tape measure, you would see that the moon is attracting water to itself by about 4 to 6 inches. The moon is gravitationally locked with the Earth. That's why it's always turned to us with one side, like Mercury and the sun. But the moon doesn't stand still. It's gradually moving away from our planet, about 1.5 inches a year. Not quickly, but in about 600 million years, it will have shrunk in our sky so much that we won't be able to see lunar eclipses anymore. Do you see this crater? It's Tycho. It's visible during a full moon because of these bright rays that extend thousands of miles from its epicenter. This is the youngest crater on the moon. Scientists say it appeared there due to a meteorite impact about 109 million years ago. At that time, dinosaurs were roaming the surface of our planet, and they may have seen the impact. It was most likely accompanied by a big explosion and looked like a salute in the night sky. Humanity loves to explore the moon. We've sent a bunch of missions there. A total of 12 people have set foot on the surface of the moon. The gravitational force there is 6 times less than on Earth. So if the average person on our planet weighed about 180 pounds, on the surface of the moon, the scales would only show 30 pounds, like the weight of an average dog. That's why the astronauts moved, jumped, and fell so strangely there. And you would be 6 times stronger on the surface of the moon. Here on Earth, the average person could lift about 130 pounds, but on the moon, you could raise a big motorcycle or a grizzly bear. The surface of the moon is covered with regolith. This is the lunar dust that covers the solid ground. Such dust is good at preserving footprints. Here's the most famous footprint, which gave birth to many crazy theories. Here's the footprint, and here's the shoe that left it. But the shoe is completely flat. This is explained simply. The astronauts wore extra boots for walking on the lunar surface. They have exactly the kind of sole that left these marks. In addition to the footprints, we left many fascinating objects on the moon. Several lunar rovers, a golf ball, flags, and human waste. There's also a lot of broken satellites and rocket parts. All in all, About 413,000 pounds of human-made objects are there. That's the weight of 3 passenger planes, or 31 adult elephants. In the future, we plan to resume missions to the moon. New landers will explore the surface of our satellite to find natural resources there. It's also a great place to test new rovers. We're even going to build something like the International Space Station in the moon's orbit, the Lunar Orbital Platform Gateway. It'll be a convenient platform for exploring our satellite and launching spacecraft into distant space. If you start from here, the spacecraft won't need to spend almost all its fuel to overcome the force of Earth's gravity. So, such a station would save fuel and money. Scientists hope that we'll be able to mine water from the moon's surface. It's been proven that there's ice there, mostly at the bottom of craters where the sunlight doesn't reach. Perhaps we'll send a rover there that can drill down a few feet into the surface, searching for water. Humanity already has the technology to build a full-fledged colony there. It would take up to 3 days to get there. We just need to get enough solar panels and building materials to the moon. There's no atmosphere on the moon, so potential lunar inhabitants would be defenseless against solar radiation. We would have to build houses underground to provide protection. Modern 3D printers will help make construction easy and fast. However, food and water supplies can only be maintained by constant supplies from Earth. The same goes for oxygen. Each rocket launch costs millions of dollars, so for now, colonization of the moon is in question. The moon could also become an object for space tourism. Imagine a spaceship launches from Earth, 3 days on the road, and you're orbiting the moon. The lunar module undocks, and you land on the surface. You ride the rover, explore the craters, then return to the lander. The engines start, the lander returns